Today on 5.3a, it should be kind of a review. We are solving trigonomic functions. So we're solving trig functions with identities. So solving trig identities. So first things first, if I wanted to have the solution fall within a certain interval, and the interval is we start at 0 degrees and we end up at 360 degrees. This is just a fancy way of saying I want it in degrees. And if we start off at 0 and end up at 2 pi, that's another way of saying I want it in radians. I want the answer in radians. If it ends up in 2 pi, that's the interval that it ends up, then we want the answer in radians. If it's 0 to 36 degrees, it is in degrees. So let's give a little bit of a reminder here. What if we had, let's say, tangent of x equals positive root 3. So first things first, we want to draw some pictures. We want to draw some pictures. I know that since my tangent of x is positive, it has to end up either be in the first quadrant or the third quadrant. So those are my two possible answers. Okay, so that is my degree. And I want this answer in between, let's do it in degrees. So 0 to 360 in that interval. From there, let's draw a picture. So let's draw a picture of a triangle here, and this will be my theta. My theta is opposite over adjacent, so this is root 3, and I'm going to assume this is 1. I am dealing with a 30, 60, 90 angle. 1 being here, it being opposite from root 3, I know that theta has to be 60 degrees. Well, one of them is 60 degrees. So one of my answers is 60 degrees. And my other answer is down here. I know this has to be 60, so it has to go all the way past 90. 60 more than 90, which is 240 degrees. What if our x, or if our angle, is in an equation? So let's do a couple of examples. So what if we had the square root of 2 sine of x plus 1 must equal 0, and I want to solve for x, or I want to find what angle that is. Well, let's figure it out. Well, we have the square root of 2 sine of x. I want to solve for x. I'm going to isolate my x. I'm going to subtract 1 to both sides. This gives me -1. Divide everything by root 2, so sine of x equals -1 divided by root 2. To find x now, I just got to figure out what angle makes 1 over root 2. So if I put in a theta here, I got my opposite, which would be 1. This is negative. It's -1 over root 2. So I'm going to redraw this triangle because I know negative sign, it has to be going down. It has to be going down into either my third quadrant or my fourth quadrant. Right? It has to be one of these two angles right here. And so here, this would be my theta. My opposite would be -1. And my hypotenuse would be root 2. So I'm dealing with a 45, 45, 90. So this here, this first picture is a 45, 45, 90. But if I represent this in radians, this gives me a 7 pi divided by 4 in terms of degrees. Here, if I went off, had a circle, went all that way. And then the other one would be pi over 4 past pi, so that would be a 5 pi over 4. And if I want to represent, because I didn't give you an interval to say, it didn't give us an interval to say, hey, between 0 and 360 degrees, we're going to rewrite this now as 5 pi over 4 plus 2n pi. 2n pi meaning gives us freedom to say it adds on a circle, and any amount of circle. N could be 0, so 0 would mean it falls within that 0 to 360 or 0 to 2 pi radians, or n could be 1, where then it takes a 1 loop, and so on. So our answer would be 5 pi over 4 plus 2n pi, and 7 pi over 4 plus 2n pi. Let's try a different one. Let's try one more. Let's say we have cosine of x times the cosine of x minus 1 equals 0. We need to find what x is. I'm going to distribute my cosine. So this gives me cosine squared of x minus cosine of x equal 0. I want to isolate this. So let's think about this very carefully. I can do math manipulation. Let's add a cosine to both sides. If I did that, if I move my minus cosine of it, did that, then cosine squared of x must equal cosine of x. And then now, if I divide everything, both sides, by a cosine of x, then divide by cosine of x, divide by cosine of x, I get cosine of x must equal 1. Okay, I can do that. Now I just need to find cosine of x equal 1. I can solve for theta in that case. Here, I need a positive, so I am dealing with angles in the first, and cosine is positive. So in the first and third angle, so thetas are 2 angles are here and here. My adjacent is 1, and my hypotenuse will have to also be 1. I got a 1-to-1 ratio. Oh, if my cosine is 1, well, that's simple, because we're dealing with a unit circle here. Cosine is positive 1 when it is at 0 degrees. So 0 degrees. So we can write that as 2n pi. Just like so, 2n pi, because that can give us 0, that can give us 2 pi, and so on and so on.